Hello, good morning, young minds. I am considering the full engineering branch here, and that's why I am saying you all are young mind. Yeah. So today's our course is applied engineering mathematics using Matlab. So first, let's see about what is engineering mathematics. Then we will go ahead with applied engineering mathematics, and then further we will try to understand that how we can implement these mathematics in real engineering problems using Matlab. Okay, and the term Matlab may be new for few guys, so let's understand that also in this workshop. Thank you. So let's start with the introduction part. So everyone till 12th have read about mathematics. Okay, so there we have learned about science of numbers, quantities, shapes, okay, and relationship between them, isn't it? But when we goes to the BTech part, or let's say some science part where we are reading more about mathematics, so there we have learned that how those equations which we have read in 12th has been extended, and we have learned more about differential, calculus, integration. Okay, so in engineering mathematics we have really learned about the application of mathematics to the real world problem. But a problem comes in the BTech part. Whenever we have read mathematics, we have only read for getting some grade, isn't it? And that's the same problem when I was in our BTech time periods. So because many students, they read mathematics not that they will going to solve some problem with that, something, nothing like that. They always study, and even our faculties not to say like that, but even our faculties teaches us like that, okay, equations, but we never realize that how we can use those equations in the real world, and how those equations are useful in industry. Main thing is that that industries require that skill or not. If we know the equations, that's fine, but if we don't know how to implement it, then it's no use for industry. So here mathematical theory, practical engineering, and scientific computing all are combined in this engineering mathematics. So there, if you remember, or if you are going through all those topics, it includes matrix, differential equation, complex analysis, numerical analysis, trigonometry, Fourier analysis, linear algebra, and probability. Even more than that, even I think 4 semesters we are spending in mathematics. But we have to understand, if someone has designed our curriculum to study mathematics for 4 semesters, it means it has a great implementation in the industry. Not only industry, if you go in the research domain also, there also it has a tremendous application. Okay, so here we can apply our mathematical methods, whatever we have studied in engineering, we can apply it in physics, engineering, mathematics, biology, finance. See that even if you are going to commerce, then also we need mathematics to be understood in a better way. Finance, business, computer science. So don't think that computer science means, or computer engineering means that we can exclude mathematics from our life. We have to include, because if you go behind the computer science, it's full of maths only. Okay, so where we can apply these mathematics, that becomes a applied mathematics. Okay, so I think first equation, I think that's the simplest equation which we have read in our BTech first year, isn't it? That's the first order differential equation. It's a beautiful equation. Dy by dx is equals to function of x. But after 4 years also, if people will not understand what is going to be useful, then it's a waste. And see that how a great phenomena is happening there. Okay, so here if you see that first order differential equation, dy by dx is equals to function of x, So let's see that where we can apply. So I am just giving few examples so that you have a glance of that how that equations, simple equations which we have read, how we can use it in a day-to-day life. Okay, so first equation means the first application where we can use the first order differential equation is in hydrostatic equation. Okay, so let's imagine one condition. You are sitting in a plane. Imagine that you are sitting in a plane, suddenly the height of the plane is decreasing. Okay, so if someone had experience, you will feel some disturbance around your noise, around your ears. Okay, what is the disturbance? That is disturbance due to the pressure difference. Okay, so if you see the general equation which we have read in our physics or mathematics, that pressure is equals to rho g h. Okay, so here if you see the differential form, let me use pen. So here is the equation, differential equation, dp is equals to minus rho g dz, where p is the pressure, g is the acceleration due to gravity, rho is density of fluid. Okay, z is the head, means where is my plane. Okay, and if you know that PV is equals to nRT, this is a ideal gas equation. Okay, if I convert, it will goes into this equation where P is equals to rho into R into TS. See, I am not going in that much technical detail because I hope that you understand, you have a little bit understanding of that. Okay, so if I substitute rho in this, you can get a first order differential equation. This is the beautiful equation with which you can able to calculate the pressure according to the altitude, and due to this pressure difference only, your ears will feel a disturbance around your, okay, around your ear. So if you solve this, you can able to get the pressure. Okay, similarly if you go in a banking firm also, okay, so don't feel that engineering student cannot go into finance side. Okay, if you don't believe it, lots of BTech students are going into the finance firm. Even they develop a model for stock prediction. If you have seen this some advertisement which says that we can able to predict stock rate of any industry, so that is also developed by some mathematical student or some engineering student who has a good knowledge of mathematics. So here if you see, this is the first order equation to calculate the principal, means the amount after a time period. Okay, so here if you see, xt is the initial amount, okay, r is the rate of interest, delta t is the our time period, and p is the principal. So if I rearrange this, you can find this one. dx by dt is the with how much rate your amount is going to increase. Okay, and if I solve this, you may get this equation. See, just here what we are trying to understand is what are the domains where we can use this equation. Okay, if you are not understanding also how this equation and those answers came, don't worry about that. Okay, don't worry, just here we have to understand, see that where we can apply these mathematics in our real world. Okay, similarly I think you all have seen this equation, isn't it? And really in my BTech time I was thinking, why we are reading this many big equations, we are solving 2-3 pages, after then only the answers are coming. Okay, but when we goes to this workshop, then you will feel that yes, there is a huge application of higher order differential equation. Okay, so let's limit our discussion with the second order. Okay, so second order means where the n is equals to 2. Okay, let's limit with that only. So I think this terminology, simple harmonic motion, everyone had heard. Okay, simple harmonic motion is very useful in the field of vibration. Okay, so let's say if you have went in an industry which is designing automobile or rail coaches, any building. Okay, so they all are solving this equation to understand that how the vibration will going to affect its characteristics. Okay, so if you simply write the simple harmonic motion, this will become d square y by dx square plus omega square x is equals to 0. I think omega is a frequency, okay, which is square root of k by m. Okay, I think here if you understand that we have one wall and spring, some mass m, okay, and spring has a constant k. Okay, so if I want to understand that with what amplitude it will going to vibrate, if I solve this, I will get this. Okay, similarly, if let's say you have to design a wind turbine. Okay, so to get a better efficiency, what we are trying to do, we have to incline the vane. Vane is the wind turbine blade. Okay, so we have to change its direction so that it will be synchronized with the air. Okay, so means let's say every time the direction of the air will going to change. Okay, so to optimize the wind turbine efficiency, we have to change its direction. Okay, so if you see, this will be written like this equation. Okay, I d square theta upon dt square plus n r by v d theta upon dt is equals to n theta I minus theta. Okay, I is the moment of inertia of that blade. Okay, theta is the angle which will going to vary. Okay, n is the speed of the turbine, r is the radius, v is the velocity of wind. Okay, d theta by dt is equals to n theta I. Theta I is the initial angle. Okay, and if you solve this, you can get this equation. With this equation, you can able to optimize the angle of the blade. Okay, so here also we are just learning that what are the scope, how we can implement. Okay, we will go in details later part. Okay, even in electrical domain, we are using this equations only. If you see, this is the figure for resistance, capacitor and inductor in a series form. Okay, and solving this problem is very tedious in the engineering problem. So if we write our equation in the series form, it will be L inductance di by dt, I is the current, plus R into I, plus R is the resistance. Okay, Q by C. Q is the charge which is flowing across the capacitor, and E is the voltage. Okay, if I write this I in the terms of Q, because I is equals to dq by dt. So if I substitute this I here, I will get a second order differential equation. Okay, and I can solve this equation and we can get the result. Even you have, I think those who are in the fourth semester or in the third semester, they would have heard about this Fourier series. Okay, and really no one teaches about where we can apply it. But if you see wherever the signals are there, okay, wherever signals are there or any waveform is there, you have to use Fourier series. Okay, so this was developed very recently in 1980s, and it has a wide application. Okay, even a lots of research is going on. Even my PhD, I have did some work on this Fourier series, and really we got a very interesting results. So here you can see this is your wave. Okay, and you want to generate a waveform synthetically. Okay, so see here, if I am using this equation and I'm changing the terms, means if I'm increasing the nth term, so what will happen, I'm getting close to this, see the red line. Okay, so red line is the result which we have developed synthetically. Okay, so here if as you have increased the terms, means nth term, so with the sixth term you are exactly able to synthesize the wave equation, sorry, means the wave here. So you can understand that this mathematics, whatever we are learning, it has a very very interesting applications in the industries. So let's say if I have even in the terms of communication. Okay, in a communication domain, we have utilized these Fourier equations in an extensive way. Okay, so here in Fourier series it describes the physical process, okay, which is useful to predict the patterns which will going to occur repeatedly. Okay, so even in musical domain, okay, where we are modifying the music, where we are generating some synthetic voice, we are using this Fourier series only. Okay, so till engineering point, whenever we have learned about mathematics, we have did calculations by hands only, isn't it? But the problem comes, do industry have so much time? Eh? They will not going to give you 2 hours to solve one problem. Okay, solve one problem by hand and give us result by the end of the day. Why? Because it will take some time. Next, it will introduce human error. Let's say today you are working on the problem, and if someone will come and again he will going to work on the same problem, he may perform some wrong errors, and that task is also tedious because you cannot do repetitive calculations again and again. It will take the same time. So that's why these conventional methods are not useful in industries, and that's where there is a huge gap between our engineering studies and the application in the engineering industries, and that's where the Skill-Lync becomes a bridge. So here Skill-Lync is given a workshop which will help you to understand that how the application of mathematics or computing mathematics is a bridge between the engineering domain and the industries, and that's why computing mathematics becoming a interesting course in MITs, Harvard. Okay, even in IITs, even I have seen various courses in IITs. Now they have started teaching computing mathematics. Okay, so computing mathematics means whatever we have learned in engineering problem, we will going to apply it, and we will going to make it automate. Automate means we don't have to solve it by hand. So for making that computing, we need a programming language. Okay, so in this workshop, we are going to focus mainly on Matlab. MATLAB full form is Mathematics Laboratory. Okay. So MATLAB, why we are taking MATLAB? Because it is very, very, very simple than C or C++. Okay, and easy to be learned for. Sorry for this disturbance. So I was talking about why we are choosing MATLAB for the programming language, because this is very, very easy to be learned for beginners, and it has a wide application in industry side also. Okay, that's why we are choosing MATLAB, which will help you to get in any industry who are working towards the mathematical side. Okay, so where we can use this MATLAB and applied mathematical knowledge. Okay, so there is a wide scope. Only we are discussing a very limited scope here in this workshop. The first one is automotive. Okay, so let's imagine you are designing an exterior of the vehicle. Okay, so if a vehicle is running at the speed of 100 km per hour, okay, if you heard about lift and drag, okay, so I'm not going in details, but your lift means which will try to make your car fly, and drag is something. So here we are discussing about the scope of applied mathematics using MATLAB in industries. Okay, so talking about automotive domain, so when we will going to design an automobile and its exterior body, okay, so we use computation techniques, okay, where we use mathematics to conserve mass, momentum, and energy equations, and use MATLAB to determine the lift and drag which is acting on the vehicle. So lift, in a simple word, is something which will make, which is trying. So lift is something which is trying to make your car fly. Okay, and drag is something which will going to retard your vehicle. Okay, so in vehicle you have to decrease the lift and drag, and contrary to the flight you have to increase the lift so that it can fly with the less energy. Okay, so that's whenever you design a vehicle, okay, it is something like inverse of flight.
So Dr. Sanjay, it seems your voice is breaking again. Your voice is breaking again. Can you just repeat this, whatever you said in the same slide for this particular slide,
I was talking about automotive domain where
your voice is breaking again, Dr. Sachin. Can you please?
So, participant, sorry for this bad internet connection. Suddenly, I don't know what happened. Yeah. So, we were talking about the scope, and in automobile, whenever we are designing every component, even let's say if we are designing the chassis of that automobile, chassis is the part where we are sitting, the frame over which we are sitting in a car. So even that needs to be analyzed. So if you understand that stress, strain, so those things will be analyzed using these equations only. Then the next thing is building. Building is something where so let's say depending on the land, okay, how the design will going to be. Even if you understand that the length and width of the column and the height of one floor is all are calculated. There is no imagination or there is no some judgment. This all are mathematics, that this much column, this much size of the column can bear this much stress. So that's why you have seen the more the height of the building, more the width of the column and more number of the columns. So every time whenever you are designing a new type of building, you have to analyze these things mathematically. You have to You have to calculate stress, strain, even you have to nowadays design your home to be earthquake resistance. So even they will going to analyze that part also, that if this much frequency of vibrations comes in the earth, what will going to happen to your home. So that's why nowadays the design of the building has been more optimized to be prone from earthquake also. In aeronautical, I think everyone can imagine an aeroplane. There's a big giant where we have applied every domain of engineering. Okay, starting from stress strain analysis means which is structural engineering. Then next thing is fluid. Okay, so that becomes a fluid dynamics. Kinematic analysis also we have to use there. Okay, so those all analysis is what? Those all are equations, and we can use MATLAB to solve those things to get into and can be helpful in aeronautical industries. Autonomous vehicle, I think these terminologies we are hearing nowadays. Autonomous vehicle which is a driverless car. So driverless means computer is there which can able to see the object. It will able to determine its shape and size. Okay, and it will going to act accordingly. Okay, what is there? There's the whole image processing techniques, and that is nothing, all is math behind it. Okay, surveying nowadays people use drone or they use satellite images. So there also maths is there. Combustion is firing, is the fire of a fuel and air. That becomes a combustion. When it goes in engine, it becomes a internal combustion engine. When it goes in an aeroplane, it goes, it's called turbojet or turbofans. Okay, when it goes to the boiler means to the power plants, it becomes the boiler. So all things are there where what we are using is using the combustion. So we have to understand how much heat has to be generated, how much thermal stress will going to be there because of combustion. So these all things will become relevant. Okay, and mathematical equations are there with which we can able to predict, okay, in the combustion related industries. Then the next thing is computational fluid dynamics. Okay, so computational fluid dynamics is the determination of flow over any surface or inside the means inside any enclosure also, and relatively heat transfer analysis also. So these two things combines and becomes a part of computational fluid dynamics. So let's take one example of industry. Okay, so in industry it has to be properly ventilated. Okay, so you are installing HVAC, heating, ventilation and air conditioning. Okay, so using computational fluid dynamics you can able to understand how the flow will going to be there inside the building. Okay, and how the fresh air will going to flow, and if any fire had happened, okay, or any incident of smoke had happened, how that smoke will going to be flow inside the domain. You are going to use the same mathematical equations. Okay, so even you have a wide scope in engines also. You can see how internal engine looks like and how we can do. Okay, this is how it looks from inside. Okay, so because in BTech time we never seen an engine from inside. So here you can see how the air is getting in, how the flow will be there inside the combustion chamber. Okay, there is a spark plug. So this is a spark ignition engine, and after combustion how the exhaust will going to be away from the engine. Okay, so let's come to the MATLAB part. Okay, so that's the interesting part of our workshop where we are going to learn that how we can solve engineering problems using MATLAB. So I think this is the simplest problem which I can able to give it to you. Okay, So let's go through it. Let me take a pen. Yes. So this is our combustion chamber. Combustion chamber means, imagine that this is a piston, and this is the cylinder. Okay. So everyone knows that piston will going to be move in a reciprocating motion. So it will going to be move in a reciprocating motion. Okay. And this is slider crank mechanism. Okay. And here is our shaft. So the slider crank mechanism will going to convert reciprocating motion into the circular motion. Okay. And this has a wide application in automobiles. Whenever we are discussing about engines and automobiles, we have to analyze this motion. Okay. And here, for this case, I am narrowing down the problem, and just our task is to calculate this volume. So this is called the instantaneous cylinder volume. Okay. So let's say this is distance x. Okay. So x is the distance for some crank angle theta. But if I am changing angle, isn't it that x will going to change? Okay. Now the question comes, if I am changing one crank angle degree, how much x will going to change? Okay. So let's remove all. Okay. So if you imagine this is connecting rod with a length L. Okay. And this is your connecting radius which has a dimension of A. Okay. So if this is a theta angle, so this distance will be A cos theta. Okay. This is A sin theta. Okay. And if we use Pythagoras theorem, this distance will become hypotenuse square minus base square. Okay. So this is our remaining length. So if I will see, my full distance is L plus A. That's the maximum distance it can travel. Okay. So x will be L plus A minus this whole distance from here to here. Okay. So this is the length which we are considering, this one. Okay. L plus A is our total length, maximum length it can cover. Okay. So means if I have generated this x as a function of theta. So now this becomes a beautiful equation. Means if I know the angle, I can able to calculate the instantaneous volume inside the combustion chamber. Okay. So let's see that how we can solve using the Matlab. Okay. Okay. Now the problem comes because you should have a knowledge. Okay, that at every crank angle, what is the volume? Why that volume is required? Because you need to introduce that finite amount of fuel inside the engine. That's why you should understand that how much volume is there at each crank angle. Okay. So what I am trying to do, so my volume will be pi by 4 d square into x. X is this distance. Okay, this one. So now it is a function of theta. So if let's say if you go in an industry and if your boss says please calculate the volume for each crank angle. So if I am not aware of coding part, what I will do? I will do by hand, isn't it? I will use my hand only. I can't do, I am not aware of anything which can automate this thing. But in this workshop, we are going to see that with a few lines, we can able to write this equation. We can able to solve this. We can able to plot this also. See this. Okay. and try to understand that what we are doing in MATLAB, we are just trying to understand and be conscious about few common terms, okay, and try to understand it how we can use it, okay. Every coding has a syntax. In MATLAB, there's a beautiful thing that they have utilized a common, okay, very general syntax so that everyone can understand and use it, okay. The first part is variable initialization, okay. So don't worry about this. This is just for comment, so that if I'm showing to you, you can able to understand what I'm trying to do. So this is just for comment, okay. So this will be not read by the computer. This percentage also for comment only, okay. So this is just for your reference. For computer reference, this part. For our reference, this part. Okay, guys. So here what I have done same. When we solve equations by hand, we, instead of writing the full term compression ratio, what we used to give, we used to make a symbol for that, so that we can use that equation multiple, means we can use that syntax again and again, and we can decrease the writing part. So here compression ratio I have defined like RC, okay. So let's say you have a typical engine which has a compression ratio 9, okay. Bore, stroke, connecting rod length, connecting radius, and this is length to radius ratio, okay. So this is syntax, okay, or you can say this is a variable and this is their corresponding constant which we have put into the variable. So this is simple how we use hand. Same way we are doing here also. Same way we are writing equation also, okay. Equation means, because we have to tell the computer what is volume, okay. So volume is pi by 4, okay, b square into s. So okay, similarly I have wrote clearance volume, which is v displacement upon rc minus 1. So don't worry about those equations, okay. Okay, we are just trying to know that how we are using this and how it will going to simplify our problems, okay. I have used theta, okay. Theta I have initialized as 0 because I want to change from 1 to 360. 360 means from the means the one revolution, okay. One revolution means 360 degree. So I want to make one arrow, sorry, make one array which will going to feed 1, 2, 3 till 360. So this is the syntax to do that, okay. Now this is the loop, okay. Don't worry about these things. Again I am saying, okay, we are just going through a glance. For loop, similarly how you have read in C or C++, or if you have not read also, for loop means I will going to compute the statement which is inside it from 1 to 360, means 360 times, okay. And what I am going to change here, vi means it is going to make a series of v variable whose first, second, until 360. So it has these many spaces, and each time it will going to compute, it will going to feed in the corresponding box, okay. And this is the equation which we have seen in the previous, okay. This is the equation which we have given there, okay. And each time I am increasing the angle because computer doesn't know, okay. So you have to tell it that I want to increase the angle by 1, okay. So here is 1. If I want to say that please increase the angle by 2, I have to just add 2 here, okay. And if I solve this, if I plot this, so this is the syntax for plot. Don't worry about these things. Don't think that is a sine wave, something related to like this, okay. So if you will find out, maximum volume is at 180. 180 means when your piston is at this position.
Dr. Sachin,
Yes, ma'am.
can you please repeat it again? I mean, like, because your voice is breaking a bit.
Okay.
Sure, thank you.
So here I'm trying to say that you have plotted this volume versus crank angle. Okay, 0 means your piston. Okay, 0 means your piston is at here. 180 means this position, because obviously your one revolution means from here, from bottom to, sorry, from top to bottom, and then again it will go back to 360. So this becomes a one revolution. Means the piston will going to move twice for one revolution. Okay, for 0 means it is at the top, 0. 180 means maximum, that's true, and 360 means again minimum. Okay, and that's why there is a symmetry across this 180. Okay, if I write this code, I can write in 5-10 minutes, and if I want to change any parameters which I have introduced in the code, I can change it easily. Okay, and if we go, okay, if we go without computation, without Matlab, what we will do? We will solve it by hand. If let's say if our boss told, okay, let's do the calculation for different parameters, again you will going to solve that equation by your hand only. Here you have to just press one button, you have to write the code. Okay, and if you press one button and answer is ready. If you have to change any parameter, you can change it. Okay, you can change any parameter and run it again. You don't need to waste lots of time in just computing again and again. So that's why that Matlab becomes Matlab made it easier, and that's why industries are adopting it. So that because industry don't have a time to solve any problem, they want to solve it faster. So that's why they are using Matlab. One more problem which I'm going to consider here. So you have seen your laptop. So laptop has one Intel processor. Okay, let's say i7. Okay, i7. Let's say you are playing some game. i7 will going to work hard. Work hard means, okay, it will going to dissipate heat. Okay, it will going to dissipate heat. It will going to dissipate heat. So there is a fan there, isn't it? There is a fan there. If you play a game which is consuming more RAM, more faster your fan will going to run. So fan is somewhat here. This is your fan. Or in recently they are using blowers also. Okay, but there is something which is fin. Okay, fin is something which is made up of copper or any metal. It is contact with the processor, which will going to dissipate the heat. It will allow to provide the more space, and your fan can make it cool. Okay, so don't worry about the equations and all. Okay, so just understand there. So okay, so in this problem we are going to just consider one single plate. We are not going to consider full. So let's say here is your Intel processor i7. Okay, and there is a fin. Okay, this is your fin, which is, so let's say your computer is working and your temperature of that processor is going to 1200 Kelvin. Guys, these numbers are not unrealistic. These numbers are realistic only. Okay, these numbers are realistic. That really its temperature goes this much high. Okay, and let's say your ambient temperature is 300 Kelvin. Okay, so this is the equation, three-dimensional governing equation for heat transfer. Okay, don't worry about the equation and all. So just understand the term. K is conductivity, coefficient of conductivity. T is temperature. Okay, X, Y, Z is coordinates. Okay, generation, E generation means if some energy is generating along the fin, that is that, and this is the if your temperature will going to change with respect to time. Okay, so means in a transient form. Okay, so let's simplify this equation, because there's the advantage of being an engineer. We will try to make the problem simplify so that we can solve it easily. So what we are trying to do, we are saying that it's a steady state. Steady state means no variation with time, no heat generation, so no sorry, steady state means this becomes 0, this becomes 0. No heat generation means this becomes 0. Okay, 1D means there is no z, means there is no phenomena happening in x and sorry y and z, so this becomes neglected. Okay, and thermal conductivity of the material is constant. Okay, so now I can simplify this, only this term is remaining, and this is the engineers what they do, they simplify the problem, and this they have converted the whole complex equation into this simple equation. Okay, now the task is how we are going to solve this. And imagine you have to solve this for multiple times, because each time you have to change the boundary condition. So again and again you can't able to solve this. So what we can do, we can use Matlab. Okay, Matlab to solve this equation and find out that how will be the temperature distribution along the fin. Okay, so as we have mentioned the problem, fin has a length of 0.1 meter. Okay, so we have to initialize this differential equation to the Matlab. So this is sims y is x. Sims is for initializing any equation, so we can provide the equation to the Matlab. Here my task is to differentiate y. Okay, see, we are providing all the instruction to the Matlab. The only, see, if you are new, it will be new for you, that's why you are feeling that okay, who it is tough. But once you know that sims means you have to initialize d square y
Dr.
upon,
Sachin, your voice, I mean, like your voice is breaking again.
okay,
It's an audio issue. Can you repeat whatever you said?
sure.
The last 2 minutes.
So guys, so we have simplified the 3-dimensional heat transfer equation to the 1-dimensional, okay, considering all the assumptions, and we have converted these equations to the simplified form. D square t upon dx square is equals to 0. Okay, so in the problem what we have done, we have considered this t as y. Okay, means because t is the output, so similarly y is the output. So let's say in that way. So what I have done, I'm trying to first initialize the equation. Okay, so I have told Matlab that this is the equation of variable y and x. Okay, y is dependent on x, that's why x in the bracket. And then what I am saying, that dy is, means I have initialized and says that differential y is my dy. Okay, that thing also I have initialized to the Matlab. Then what I am trying to do, I am trying to solve the ordinary differential equation. Okay, so that's why I wrote ODE. Okay, what I am doing, I am forming an equation, differential equation of d square y by dx square. So here first variable is y, means the dependent means the dependent variable, this becomes x is independent, and then order 2. See, with this simple form, I have written the differential equation and told that Matlab, this is the equation. Okay, our coefficient is z0. So if you see, this general form is plus, if I'm writing 0 here, so it will come here. Okay, then we have to provide the conditions, means the boundary conditions. Okay, so that is condition 1, condition 2. What I have told, that fin base temperature is, okay, in this we have done it in a different way, I think. Okay, so in this what we have told, that our base temperature is 300. Okay, in this Matlab code we have done it like this, and our end temperature is 1000. Okay,
Sachin, your voice, I mean, like your voice was breaking again.
okay, so here what we are trying to do, condition 1, y0 means y bracket 0 means for x is equals to 0. So what I have said, that for x is equals to 0, temperature is 300. For x is equals means for the tip point where x is 0.1, for their temperature is 1000 degree. Okay, so I'm providing it to the, means I'm creating one array, and see these two equations. Okay, these two equations is the fundamental which will going to solve the ordinary differential equation. So you have to just type dsolve in a MATLAB, ordinary differential equation. So if you see here, this is your ODE, okay, and conditions. That's why you have created one array of the conditions, okay. So this will go here, you will solve it, and you will get this same result. This is the result here. Now, why we have to do this? So let's say if we have to calculate the temperature distribution along the length of the fin, I can do that. If my boundary conditions get changed, I can change it right now. I can press one button and I can able to compute it. Okay. So that's the easy thing, and don't see this way. This is just for plotting purpose. You will see more details later up. Okay. Similarly, one more example, just in extension of the previous one. Okay. So here I am considering that some heat is generated. Okay. And generation is something with respect to temperature, means as the temperature will go high, my heat generation will be more. Okay. Here again I have done the same thing. So if you are doing by hand, again you have to solve that equation, but here I have to just change this part. See, in previously we have written 0 here. Okay. In the next I'm converting to this differential equation, so I will write minus 100t. Once I will write minus 100t, boundary conditions are same. I don't need to change anything here, not even here. Just see, modifying one single statement, I can solve the different problem. Okay. And see, my answer is also different. In the previous problem, the temperature distribution is linear. Okay. But in next problem, when we are talking about the heat generation, the temperature distribution is non-linear. Okay. So this becomes the function of x. Okay. But not in a linear form. Okay. So this is the equation which we got. Okay. This is the solution there. Okay. Thank you, young minds. Hope I know that MATLAB is new for you, but believe me, this is a very easy tool. Once you have to use it, and then you will be master of this MATLAB. Okay. Yeah.
So, Dr. Sachin, can we just wait for a minute or two?
Sure. No issues.
So, participants, if you do have any technical questions, you can just drop here.
Even if someone is in different domain and they want to know where we can use this, what's the scope. Okay. If you are looking for some industrial information that really we can use this course there. So this means the platform is open for any kind of question, not relevant to this anything, means not needed relevant to these equations only, even towards application domain, to research domain. Okay. Please shoot any question.
Sure. So there is this first question for the day, Dr. Sachin. So it's like, with respect to CFD, are there any advantages MATLAB has over other softwares?
Thank you. So yes, it has advantages. Such first thing is, so it has inbuilt tools. So let's say if you're talking about the solving differential equations, so they have the inbuilt tool with which you can able to solve this complex differential equations also. Okay. So I was trying to say that yeah, CFD when we use MATLAB over any other software, it has various inbuilt codes, means predefined codes to solve complex and non-linear differential equations also. Okay. And let's say if we have to solve governing equations like mass conservation, momentum, and energy. So we have the predefined codes with which we can able to use this and directly able to solve our problems. And the second thing is that you can miss one more advantage is that you can make it a more graphical way, means you can able to solve and you can plot any kind of contour using MATLAB. Even there is a lots of extension of this, so that's why various industries they use MATLAB for CFD purpose also.
Thank you. So the next question is, So how can we start programming in Matlab?
Mm, how we can? I think that's a very interesting question because. So first thing I will tell, I would like to tell that MATLAB providing a free version, even you can use online. So I will recommend if someone is interested to learn, please install MATLAB first and try to do the basic things like addition, multiplication, then designing your own calculator, and then solving a small differential equations in the MATLAB itself. So you have to go step by step, and one day you will be a master of this MATLAB. And I think YouTube, I think I have, and I think Skill-Lync also has a few courses which will be very helpful to you if you have if you go ahead to learn MATLAB. And yeah, I think that's the way. Means practice is the best way. I think what I would like to say.
Perfect. So thank you very much, Dr. Sachin. I think we do not have any other technical questions as of now. Thank you. So is there anything else you wanted to cover before we wrap the session?
Yeah, just I want to say that because of limited time, we have just covered a very narrow domain of applied mathematics. Okay, so it has a wide, really, it has a wide application. Okay, which I have learned during my PhD at IITM. That really means without math, I think industries how they will work, I don't know, but really, but in research side, it really helps a lot. And what I felt that after BTech, there's the problem which will be which people face is because they even because after then we don't know that how to use that mathematics. Okay, so what I will recommend, please, if you are looking if you're going through any mathematical problem or mathematical equations, try to find out where we can use it, how we can use it, and how it is relevant to industry. Because at the end of the day, if you're looking for job in industry, your skills should match with them, and the competition is so high that really, guys, we have to gain more and more technical skills which is relevant to industries nowadays. Okay, so that's what we have to change our mindset. Instead of just learning some subject or mathematics for grade, we have to see that how we can apply. So that's all. Thank you, Nageswari. Thank you, young minds.
Thank you very much, Dr. Sachin. Thank you once again for the session.